Hi, good good evening, good morning, good night, wherever you're located. Welcome to the next generation of technologies, the Pandit Madan Mohan Malviya National Mission on Teachers and Teaching, uh, the Faculty Development Program under the Ministry of Education, run by Ramanujan College, University of Delhi, Teaching and Learning Center. This is a 2 weeks refresher course in computer science. And in this respect, today, uh, myself, Prakash, welcome you all, the faculty uh, and the teachers and research associates. Um, I am Prakash Ramchandran. I am the secretary and co-founder of the Emerging Open Technology Foundation. I have a startup mentality. I have done several startups and some succeed, some fail, but currently a senior member of IEEE CS, ComSoc, and co-chair of Edge Working Group for the next generation future networks, and active contributor to optical as well as AIML, and co-chair of the Edge Working Group as you saw earlier. So last 3 years I was with the as a board of director for OpenStack, and currently I am the secretary for Open Technology Foundation, Emerging Open Technology Foundation. My past is I have passed out my MTech from IIT Bombay, IT batch, and worked for this industry all over. Speaker for last at least 10 years, focused on cloud, telco, edge, IoT, 5G, and also I was assisted what do you call the education system in India, early 80s. Uh, so what we are doing here is we are focusing on 5G, which is my favorite topic, and especially I want all of you to learn from whatever I have collected over years of my efforts. Uh, so the vision here is to focus on the 2030 India's GDP to reach the 10 trillion. To help this, we are building teams both in US, India, China, all over. And I have traveled worldwide to understand the implication and hope I can provide you the necessary uh, material on 5G, on the datacom, both the core and the edge. So let's take the peek at what is our agenda for the day. This is the day 5, session 1, and we are focusing on Magma as one of the software for 5G core. So topic 5G radio and core integration we are dealing with. So we start with the core first, and we will begin with orchestrator. What is an orchestrator and what's an access gateway? The big picture, what Magma brings to the table as a software for the radio, and its aspect of reliability, which is mainly due to Facebook, and its source mainly due to OAI, and its focus on upgrading to 5G. And overall, we'll see what are the 5G system aspects, what are the user plane functions. We'll cover then the 3GPP integration through FEG, or what is called a Federation Gateway, and we'll look at the questions to ponder. How Magma demo is there, which is external, which I will not show, but it will be available to you. And what is the next session? We'll look at it for the 5G radio side of it, more on the datacom, and the last one, which probably will bring you later, which is the private 5G network, use case of private 5G network. So let me begin here with Orchestrator. So why on the earth we are starting with Orchestrator? Obviously, Orchestrator is a key piece in uh, configuring and interfacing the entire 5G system. So if you look at uh, Orchestrator, it is the piece which puts everything in the right place through commands. Uh, so here the what we see is there is a eNode B, which is nothing but radio um, for the 4G LTE, and orchestrator is connecting to the functionality, which is here you can see in this box, which is nothing but access gateway. So what we see is the implementation here is largely related to functionality of the access gateway, which the orchestrator manages, which in turns supports the radio gateways like eNode B. It could be any 5G node. It could be a instead of a 4G LTE node B, it could be a G node B example. So any radio, it can even be Wi-Fi. So all the radio is uh, hidden to the access gateway functional as abstractions, and it only deals with the interfaces and passes the information to eNode B to be able to connect to the radios which are there, different radios. In this case, it is eNode B. So the picture on the right side, what you see is functionality of all the modules associated with a MVP, in this case, minimum viable platform, which is what we have been doing on the beta trials for the community side of it. And federated gateway is not shown here. So orchestration orchestrates through access gateway the access for the user equipment or the mobile terminals to connect through the EPC, which is the evolved packet core, first going through the eNode B and then connecting to the uh, EPC, which is the second part, which is the core part. And then, so eNode B is the entry point for it. And then you got all the EPC and which is connected, and then thereby all the packet core functionality is performed, whether it be in the 4G LTE or in the 5G aspects of it. So let's look at the functionality what you have in this. So you have access control management, subscriber management, and packet processing pipeline. Packet processing pipeline is more of a user plane function. Let's drop it right now. So access control and management and subscriber management. Now the subscriber management can be local in the access gateway or it can be remote. If it is remote, then it has to be got from where it exists. Example, it will be, then in that case we have to involve access gateway, which is not shown in the picture. As orchestrator, Magma orchestrator can be used standalone with access gateway without having to deal with the federated gateway, provided it's a Wi-Fi or it's a standalone implementation. And in the standalone implementation or in any implementation, you need to manage the device and you need to manage the services. Here the device management is not shown, but we'll see in the next picture what it is. But session and policy management is shown, which is part of the subscriber local if we have to do local. And also optional services to go to the customer premise equipment to ping, etc. is there. You can do telemetry and logging, which is part of the system features. And then in the end here, you see that 4 protocols which you have shown. Those are the 3GPP protocols for the home subscriber services, packet charging rules function, online charging services, and mobile service center, and very HLR, VLR, which is home location and visiting location registers through the respective interfaces S6A, GX, GY, and SGS. So this is part of the federated gateway, or a FEG, what we call, and that will be connecting through the orchestrator. He's not shown here. So why we start with orchestrator is the one which is the manager of the system, and in this case I'm talking of the 5G core, which is what we are up to here. And the core system needs access gateway. One access gateway can connect to one of the radio devices. In this case, it is eNode B. Let's go to the next picture and get more detail before I jump into the big picture. So yes, So we are here into big picture. The essential part, what I want to bring to here is uh, this is showing end-to-end interaction between the UE and its uh, registration, which is done through the NAS, they call it, which is non-stratus access, non-access stratum, which is probably in this case not shown here, but it goes to the federated gateway. But that is provided your registration is external. If it is internal, then you can do in your own local database, as we mentioned earlier. Also, subscribers in the local database, you can do it, or you have to import it from the federated gateway. So, assuming that those are available, then your radio base station, which is here, that's the key. So a user equipment with a user ID, which is established in terms of either a SIM or equipment, device equipment, connects through the access gateway, which is over there in this case, as you can see. Because if you are talking of physical layer, the physical layer being air here, it is over there. So the UE connects to the radio frequencies to the cell tower, and cell tower connects it in turn to the through the G node B or E node B, which has nothing but radio base stations, which are radio base station is a old term. You can use the next generation RAN, NG RAN, to depict it. And so the connection goes through this, and then Access Gateway has already installed the RBS, that is the G node B or E node B, and it is also installed the various hardware, software, and all that. So assumption is Access Gateway is the one through which you do connect to the existing as well as built up new servers or stop and start and all those things. So orchestrator is nothing but a control plane and central control plane, and that control plane allows the APIs to access the access gateways and configure everything, like configure the all the gateways and through the API access, and that enables the system to be built, and which the UE uses to connect through the cell and then passes on to the radio base station, which is in 4G or 5G, which in turn then connects the bearer and establishes based on the AAA functions, which then has it goes through the federated gateway to get the if it is what you call a 3GPP interface to one of the operators, then it will get it from there. Or if it is a local Wi-Fi, then your subscription database internal, and as a subscriber, you are allowed to access, and then you create your bearers end to end, and this can be to the data network which you pass through the core. So basically, packet core is here, 5G core. If it is a 4G core, it is serving gateway, packet gateway, either together or separate functions. Or serving gateway is nothing but a private DNS type of thing to allow you to choose the gateway. Very similarly, you've got user plane functions here, which is the main packet core for the 5G, and that connects. Once the connection is coming, it will be registered, and once you register, then you get the that is after AAA authentication, authorization, and accounting are all established. Then you will be able to create a PDU session, that is the packet data unit. And then once you do a packet data session, for which the IP generally in 4G it comes from the packet gateway, from the 5G it will come from user plane function to be able to get you some what do you call IP to the device. Once you are at the IP layer, then you can do the access through the tunnel that is established, and that tunnel allows you to connect to the service. And the service is usually, when you talk of service, there are two types of services here. This service management which is there, it is part of the internal services. So internal services are like you got the monitor daemon, and you got the redirector and the connection tracker and telemetry, uh, tracking the UE connection and events and alarms and all those things. So those are internal services, and other is the device management. In the device management, you got the Magma daemon and DNS daemon and health checks. So those are the things which are managed by the access gateway, and through which these services the user connects through the access front hall, the metro, the mid hall, core, the back hall, and the data cloud, which is in the uh, what do you call, uh, either cloud, or you can have a data, they call it as a break at the metro level where centers are there these days, the edge cloud. So you can have a connection to the edge cloud. So these are the pieces which are there, make the whole system. And then these were developed with tip workstream one, mostly focused on the migration from the source code migration from the PGWSGW to the user plane function and the uh, access management function and session management function. These are the three main functions which bring together the core, or the which bring together the 5G core to be able to be connected to the access gateway through access gateway management, and then allow the UEs to connect and uh, operate and disconnect and do the paging, do the QoS, all those kinds of things which are related to the user plane function. So this is how the whole big picture is, and this evolved over a period of time, at least 2 years to 4 years, I would put it. And currently, it is in a state where you can apply it to 4G LTE. It is working, and it is in the beta for the 5G modules, which is the AMF, SMF, and the UPF, and all other uh, modules which are external have been connected. 3GPP related have been connected to the federated gateway, and this is cloud native because it is using uh, everything as uh, able to do through APIs and microservices, and that's the thing. And the code is uh, so. What has happened right now is at this stage, it has moved from tip to Open Infra, where they try to do the CI/CD, and followed by it, Linux Foundation facility has facilitated by offering additional resources, and the merging of all these efforts makes it likely to succeed, more likely to succeed, and alignment is happening as we speak, and operators and vendors are all lining up resources to deliver the milestone. You can refer to the community source code at github.com, magma, as you see here. So this is the picture as we see, and obviously network management system services is available. That can be a optional module which you can use by having all those services clubbed together into through NMS. So access can be through NMS. Additionally, you can also look upon this orchestration central piece, which is the configuration of API and all. This can drive in itself as a mobile network operator for Wi-Fi, or you can even connect it if you have your own pilot cells or some cells which you have got unlicensed spectrum. You can connect it internally if you are in a campus environment and deliver your own MVNO type operation, or you can connect it to the external operators like Bharti, Airtel, or it could be Reliance Jio, some others who are participating uh, as a gateway, and connect through the orchestration module, which offers APIs to the operators. So if the operator OSS BSS want to use the orchestration of uh, Magma, they can use the API and connect it. Even you can use own app on top of it instead. So whatever management module you want to apply can use the orchestration. Therefore, orchestration is the key piece in this. All other access gateway, there are three pieces to this at the main pieces. Orchestration, there is a control plane, central control plane. You can have other control planes lower down uh, based on the access gateway. You can have one access gateway, and you can have n radios, or you can have multiple access gateways as shown here, and each access gateway managing around dozen of radio base stations, or next generation radio. So that's how you connect. This is the bigger picture that tells you that the entire functionality of 5G core can be wrapped up into the user plane function along with the radio base station connectivity. So you got the cell tower, you got the, so the access is managed either internally or from external 3GPP mobile network operators or MVNOs, and then you can have the what you call the metro piece, which is Ethernet mostly. So there is a convergence of mobile and fixed at metro. So there is your mid hall or front hall, mid hall types. Front hall is mostly in the radio area here, where you try to connect from the cell to the back end to the data centers where the applications are running for the edge, or data centers which are running in the cloud, which is a longer distance beyond the core. So either way, you have to use the edge, metro and metro hall, and then you go to the core, which is in the back hall. You have 5G core, which is what I mentioned here. This is the back hall, and then go to the data cloud, which is in the center. It could be IMS, could be one of those enterprise data centers where applications is being served. So this is how the Magma is. It looks as if it is a software-defined networking plus the addition of management and control plane and the user plane all in one Magma, and it's a orchestration central uh, control plane which is configurable with API access. So this is a big picture. Let's move on to uh, other services like after the main functionality of 3GPP is implemented through the software and the associated underlay hardware and all that, servers and computers and storages with virtualization, with containerization, all that. Then the question comes is how do you manage those elements? You need to have AGW access gateway to instrument telemetry required to assist in monitoring, troubleshooting, call tracing, event tracing, alarm display, so there is a NMS optional, which is if not NMS, the OSS will replace it with their own NMS. Either way, that is the operator OSS, BSS will replace, provide the NMS for it. So either way, we assume that equivalent functions of NMS, which is providing the graphical user interface to manage the uh, devices or the servers and the daemons which are running, that can be uh, collected, that can be pinged, and their health can be checked. They're on off, they need to be rebooted, they can be rebooted. So all this happens from the network management service through the access gateway, and the access gateway are obviously working with the coordinating with the orchestrator. So whatever need to be collected and can be collected like logs and analyzed later. Same way you can events related to uh, accessing the gateway, whether the services need to be restarted, etc. You can find out. Events related to subscriber, example, session started, ended, all that can be recorded and logs can be obtained. Events related to MME, example, subscriber, attach, detach, all those functions can be also be viewed. Call tracing is end to end. You can say what time you called, what time you close, or what how much of data you consume, which may be required for the based on the policies applied from the uh, PCRF in the mobile network operators domain through the federated gateway to the subscribers which are in the control here of the access gateway to talk to the respective uh, Bs, which in turn connect to the user ID, the user equipment, that is the SIM and the EME ID or MC or whatever you call. So either to the device or to the user or to the application or to any of those IDs, including APN and all, it will be able to determine and provide the necessary connectivity detail and tracking the details of through the orchestrator API. Uh, so these are used for troubleshooting, as you know. Uh, there are different ways of uh, cloud-based technologies to differently the observability and the telemetry, that is the telemetry and logging and time series data collection and all that, which is different from what the probes do in the in the 5G core earlier in the 4G LTE, which are very expensive. So here you can obtain, certainly you will also need to scale this up, but given that the This is scalable and is cloud native. It also helps us to do the work much effectively and more in a more automated way. So AGW implements the user plane and some aspects of the control plane, as we said here for mobile core. So it operates under the control of orchestrator as you saw it. It is responsible for one or more base station. Yes, of course, you have one-to-n relation uh, between the orchestrator and the access gateway, and the access gateway is one to n two, which is around dozen, you can say, reasonable number to establish um, probably one market segment or maybe multiple market segment, if depending on the user base and the density of the nodes, depending on whether it's a 4G LTE or 5G. So what we see from here is the goals stated for AGW architecture is it should be heterogeneous. That means you provide diverse radio access technology supported without impact to most of the architecture. So the architecture is neutral. It will support any of the access technologies, and you have to hide the access technology, radio technology behind the E node B or the G node B or whatever, but generic interfaces are available, and you anyway you are going through grpc internally, so rest of the things fall in place since it's all cloud native. Then coming down to network level management, here the base api is available from a single point, that is from the orchestrator, and therefore everybody can use it, so that goal is met. Network level management. Then the one thing which we need to make sure that for the fault domains, because fault means if you have some fault, single point of failure, you have to ensure that you avoid failures and you are able to recover from the. So one is to do everything stateless, the other is to do with station. Since all the statelessness, all are stateless, except that you have everything in the uh, what do you call the key value pairs in the microservices uh, saved as the state, so one can recover from the state failure very easily, whether it is a federated gateway or whether it's an access gateway. All these are manageable because of the current what do you call architectural which is based on the cloud native principles. So optional services, as you said, includes the customer premise equipment. You can ping and you can get the detail. So all these event logging, tracing, troubleshooting, all of this is available to the both access gateway and the orchestrator, which is working to provide us the uh, level of confidence or uh, site reliability or service reliability, which is essential for the finites of this maintaining the 5 minutes failure in year type telco types cloud. Let me go on to the user plane. User plane, here we have got the open vSwitch. So in the last diagram at the bottom we said user plane function. The user plane function, which is the UPF, does uh, establish tunnel, and those are GTP U, that is user plane function, and GTP C, which is the control plane signal. So the control plane signal also need a signal bearer, whereas the user plane require a data bearer. So both signaling bearer and data bearer are established at the layer 2 because it is over there on the radio side of it, and then it connects to the terminates on one of those uh, gateways. And once it terminates on the E node B, from there onwards, it is connected to the uh, source of data or source of application, which is ending in beyond in the data network. So the tunnel, it is a single tunnel or two tunnel or one hop or two top tunnel based on the termination. But the IP is allocated in the packet gateway or the user plane function, and therefore once the IP is allocated to a device like a uh, subscriber with a UE or a SIM, then they retain that IP until it expires. Again, they can get the new IP or the same IP is, if it is DHCP based. So it depends on how you do the packet processing pipeline. So the pipeline is established using the Open vSwitch, and Open vSwitch is the one which has got the monitoring allowed through the OpenFlow as well as SFlow, and many automated controls are there. So management protocol in this case is the you got the OVS DB for the stateful, and open flow is a known open flow 1.3, 1.4, 1.5, and so those are the various standards available depending on your uh, implementation of OVS, which has got many versions, and depending on the compatibility and versions, you can manage your traffic through the Open OpenVSwitch. OpenVSwitch is more to do with the node level and the VM, so that VMs can be managed with the virtual switch, whereas the in the data centers, the physical switches which are on the networking side of it, they are on the racks mounted. Here it is in the server. So the communication between the Open vSwitch and the switches which are there in the data center uh, in the uh, hierarchical way, which is for managing the throughput properly. So those are standard at the underlay layer, and overlay is what we are dealing with here, and this will take care of that through the BGPs and what do you call the MPLS, which are there in the underlay. And at the overlay level, we'll be able to do IPv4, IPv6 connectivity for establishing the session. And in the data plane, the packets are processed. So you can have packets per second. You can measure all those benchmark it. And you'll find that this is quite stable and reliable. So the two aspects which I was mentioning, one, Facebook took the OAI code and uh, it forked it and then tried to establish the reliability and site reliability functional use on the 4G side of it to start with, whereas OAI continued with its efforts to embrace the 5G. And at the end of it, once this has been implemented for 4G LTE by the Facebook and by the TIP and the other providers who are participating in the TIP, it has now come to bring to the fifth generation, and therefore you will find some of the changes obviously are needed in the data plane besides what you have in the VM, like you have container networks, Calico, and which operated the layer 3. So those are possible, but those are ongoing efforts as each service provider needs whatever they need. They try to establish a team and produce various uh, additional services they need. At the baseline, it is open source and it's available, and most of the people contribute and take what they give and take, and so it's an open source project, well established and very good to use. Especially in the user plane, you will have more opportunity to innovate, which is what is currently will be the next phase as the control plane of the Magma, which is what is the key piece established with the orchestrator and with the federal gateway. So what you see is here, there is a mention that packet processing place can be enforced. So the pipeline is being established. So not just the open flow alone, but there is a pipeline, and that pipeline is supported. So you can provide the uh, service level service chaining or service integration, microservice integration with proxies and other things as commonly done in the industry. If you want to do something at the higher level, example, if you want to load balance, you can look at the layer above the IP, so that you know you can have a virtual IP. If you are going to do further, like example, I want to know only manage the Zoom traffic, then I may have to go to the application layer, layer 7. So you have to do deep packet inspection and make sure that whatever your application is there, you are able to optimize it. And those are the things which are more like uh, need basis and can be done. So user plane function is stable, but you also have innovation in this area which will happen. So going down to now, Magma, can you use it as a greenfield? Yes, sure, because it's a standalone. You can do it standalone, as I mentioned earlier. Being part of the, also there are separate Wi-Fi stacks available for this. So you can connect with Wi-Fi. You can also connect with Wi-Fi 6, Wi-Fi 5, Wi-Fi 6 and Wi-Fi 6E and all those, which are nothing but newer versions for 5 gig and 6 gig. Usually 2.4 and 5 is the ISM band where you use the Wi-Fi unlicensed, and you can now get even into CBRS, which is in the 6 gigahertz, and internationally, even in India, certain uh, uh, openings are being made, and so you will find that everybody can use it. So given Magma, we deploy the Magma standalone, which is greenfield, but most often it is done with other existing operators or MNOs, and therefore what you do is because new radio alone doesn't work in 5G. You have to start with the uh, SA, which is the uh, so standalone is the greenfield, but you have to work with existing. So you do a LTE backend with a new radio front end, and that's the normal way of deploying. Uh, 3GPP has got its own release 14, 15, 16, and all that. And here we are focusing on the cores. So I will just say here that Magma is can be implemented for brownfield. If you do for brownfield, then you need to have all the billing, the policy, the subscribers, all that you have to import. So that is where the you go to the operator core, the MNOs, and as you see on the right side, all these services which I already mentioned, you import the subscriber and all other devices and whatever you need to be able to support from the connection and the flow between the UE and the operator, and that is always done through the orchestrator. Orchestrator is the piece through which you have GPR. You can see gRPC, HPT2 plus TLS. So transport layer security you use with HTTP, or you do with gRPC, either way, and then establish the uh, uh, tunnel end to end if you can, and then that's how the flow occurs. And that TRO69, which is there, is the front side, which is access side of it, which is the standard adopted for the user side equipment connectivity and all that are the more likely the the cell tower connectivity with the access gateway, and then that is the 5G core to cell tower, and from cell tower you got your standard radio access, which is over there. So what I would say is the once there is a clear need to establish whether you are dealing with blue field or green field, you can deploy, and then make sure you import all the necessary uh, subscribers, and then either orchestrator is able to just view what the subscribers are, and then deliver whatever the MNO asks, or MNO can permit, if they want, to allow operator to operate from the Magma console itself, which is the NMS console. Both ways it is possible. Most likely scenario is that use case will be MNO will only want to provide the uh, local, they will like to federate the existing network, Magma network devices, and expose it. Now coming to federated gateway, we said uh, it's obviously tasked to augment the existing capability of the uh, Magma to support interface with the uh, operator core, the four functions which we spoke. I would say at this time that you can definitely use Linux Foundation course LFS1666 on Magma, and it's good for beginners to get a feel of it. It's a very good course. I have gone through it, and I'm pretty sure that you'll learn a lot about what is and what is not, especially what how they are isolated and yet they are powerful. And in place, you can provide functionality, and you can add your own modules and all that. So these are some of the things. Uh, uh, Fred obviously handles the control plane connections and uh, to the operators. Okay, when access gateway handles more to the radio functions. So these two are a different domain, and not different domain, rather different purposes, and both don't talk to each other directly. They always have to through orchestrator. So orchestrator is the key piece whereby anybody interfacing to orchestrator can get done what they need, how they need, modularly at the same time, meet the principles of cloud native services for microservices based on the devices and services they bring into work with Magma. So at this stage, I will just uh, think, or rather, we brood over some of the questions like to create an idea of what we did. Like example, here the question is access gateway and FEG are the um, federated gateway do not interact directly. Is it true or false? Yeah, it's true. They don't interact directly. That's the beauty of it. That is why you are getting the orchestrator to be able to provide connectivity between the two, as well as to the external, as well as to the NMS, which is a optional module. Then going to Magma cannot manage its own network as a greenfield. No, that's not true. Magma can have its own greenfield. That is the Wi-Fi implementation example I gave earlier. So it's a false. Magma can manage greenfield. That is, it can be the um, what do you call the genesis, what we call to start with, of any network you can have in campus. If you are freshly doing in campus network, you can use Magma as your greenfield management console and implement all the Wi-Fi, etc., and as well manage the connectivity to the mobile network operator through whom you are getting the mobile access to your uh, what you call the teachers and the employees and the staff and all that. Now, service provider OSS BSS can use Magma Orchestrator API for Magma NMS GUI to view or manage 2G, 3G, 4G, 5G network. Yeah, you can manage any network. And subscribers using 3GPP protocol interfaces like S6A, GY, GXS, GS. Yeah, this we said this is, yes, they can manage, and this is true. So basically, 3GPP and interfaces and Magma internal interfaces, they are on a different uh, areas. One is on the cloud side of it, cloud native side of it. The other is more to do with the 3GPP interface and the protocols. In either case, both of them can interoperate. That's the key, because you have got the gRPC. We can have the metadata associated and provide the necessary elements as well as the packets that are necessary to uh, create the session. And it's a two-way. gRPC is two-way, and it is multi that means you can have multiple messaging with queuing and all that, so that automatically it will be queued and dequeued. And so it's a very fantastic protocol based on protobuf. And so it's a well tested and well used, and most of the people tend to use gRPC these days. Then going to the Magma support for Wi-Fi. Yes, it can support Wi-Fi. Will it support 6E? Yeah, you can. Somebody has to step in to do that. But radio-wise, Wi-Fi 802.11, A, B, G, C, and all this N are all supported. 6E is a bit of a different new radio, you can call it. Like you have a 5G new radio. This is a Wi-Fi new radio for us. So it just depends on the what band it is, and we can configure those, and then hopefully the radio portion works based on the signal to noise ratio being proper and everything, and then you should be able to, and all the encryption, decryption, and mm, modulation, demodulation, all of them are taken care. Then in that case it will work. So those are, once they are available, they should be easy to fit in. Now Magma supports cloud native services using gRPC to keep its internal communication as well communication to FEC to interface for 3GPP. Yes, that is correct. This is we have seen. So the reference materials are available to you on the what do you call the GitHub, which I pointed earlier, and also there are many recordings available, and you can go through them. Uh, the demonstration by uh, uh, Shubham Tattvamasi from Ramanujam College, Delhi. He's a research associate. He has done the entire implementation. It took probably a week for him to set up everything. Maybe I may be understating or overstating, I don't know. But what I saw is I interacted with him. Less than a week, he could get things going once the systems were ready. And it takes a few hours to demonstrate, a few minutes to demonstrate. In fact, this is just a 5-10 minutes YouTube. You can watch this and you will understand how using the bicell, how he has connected the cell with the uh, core, that is Magma core on a ARM. It's a Raspberry Pi kit where he has done, and you can connect and you can demonstrate. So demonstration is easy, and if demonstration is easy, next step is only to make sure that you choose a proper distro of your Kubernetes or something where you want to use and deploy all this either in containers or even in OpenStack. So choice is yours. You can choose what you want and be able to uh, production worthy implementation you can do with the CI/CDs. So that's all I have for the 5G session. I think I will pause here or stop here so that I can get the recording before I move to the next session. So let me just uh, stop recording here. Stop.